Tonight, when you look up at the night sky, it may feel like you're seeing everything, but in reality, you're seeing almost nothing. Hidden in the vast darkness, far beyond what our eyes can detect, there are billions of invisible worlds. These worlds orbit distant stars, silently, endlessly. Some of them are burning infernos, some are frozen wastelands, and some might be very similar to Earth. These mysterious worlds are called exoplanets, planets that orbit stars other than our sun. Each one is a completely different world, with its own environment, its own temperature, and possibly its own form of life. For centuries, exoplanets existed only in theory. The reason is simple: they are incredibly difficult to detect. Planets don't produce their own light, they only reflect the light of their stars. And trying to detect one is like spotting a tiny firefly next to a massive lighthouse from thousands of kilometers away. So how do scientists find them? They use a clever technique known as the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the star's light. This small dip in brightness can be detected by sensitive telescopes. Imagine watching a distant streetlight, and for a brief moment, a tiny insect flies in front of it. The light dims, just slightly. That's exactly how we discover most exoplanets. Once a planet is found, scientists search for something even more important: the habitable zone. This is the region around a star where conditions might allow liquid water to exist. Not too hot, not too cold, but just right. Earth lies perfectly in this zone. But being in the habitable zone does not guarantee life. A planet must also have the right size, the right atmosphere, and protection from harmful radiation. Too much greenhouse gas, and the planet becomes like Venus, a scorching world with temperatures above 450 degrees Celsius. Too little atmosphere, and it becomes like Mars, a cold, lifeless desert. Now, here's where things get interesting. One of the closest known exoplanets is Proxima Centauri b, just over 4 light-years away. At first glance, it seems promising. It's similar in size to Earth and lies within the habitable zone. But there's a problem. Its star is extremely active, releasing powerful radiation bursts. These could have stripped away its atmosphere, leaving behind a barren, lifeless surface. Another fascinating system is TRAPPIST-1, 7 Earth-sized planets orbiting a single star. 3 of them lie within the habitable zone. It sounds like a perfect system, but again, there are serious challenges. The star emits intense radiation, and the planets are so close together that gravitational forces create extreme conditions. Even advanced observations suggest some of these planets may not even have atmospheres. Then there's Kepler 442b, one of the most promising candidates ever discovered. It's located in a stable habitable zone and may be rocky like Earth, but it's over 1,200 light-years away. So far, we know almost nothing about it, and that's the biggest problem. A planet being potentially habitable doesn't mean it actually supports life. It only means the conditions might be right. Even on Earth, life took billions of years to evolve. And there's another possibility. What if life exists in forms we don't even recognize? We're searching for life based on what we know, but the universe may be far more creative than we imagine. There could be billions of habitable planets in our galaxy, but for now, they remain distant, silent, and unknown. And somewhere out there might be a world just like ours, waiting to be discovered.